Hello, hello, hello. Good afternoon, Internet. You just boot myself up here. Here we go. Oh, look at that. Here we are. Welcome to another NL Math Man Math Help stream. I'm here currently getting right up by the big old tongue, the big old doggy tongue. Oh, slurp, slurp. There it is. Yeah, little sister. We see a picture of little sister Flurry getting her ear cleaned out by brother Smokey. How nice. How very idyllic and pastoral looking in the background. Yes, isn't it quaint? Hmm. It's wonderful, right? I mean, that's why I got NL in the name, right? Because we're, you know, quaint and pastoral. Quaint and pastoral. Um, definitely pastoral. That part is true. So anyway, yeah. Hope distance teaching is still going well for everybody. Topics for today. We see we got some new technology over here that I'm showing off today. Got I don't know. I mean, it's just it's just typed text with a border around it, right? But it's new. It's good. It's good tech, right? I'm not just pointing the camera at my paper. Although, don't be fooled. Don't be fooled, Twitch chat. I am indeed pointing the camera at a paper. Oop. This was a different window. This one was supposed to be a surprise. You weren't supposed to see this one yet. You weren't supposed to see see me out in the pond yet. Okay, hold on. Here we go. No, that's better. Now we're back. Now we're back. We're back where I wanted to be. There we go. That's good. Good. Let me get that. There we go. Nice and positioned. Okay. I think our level of blue should be good for the day. So let me just switch back over to my intro page. So we see here now what the topics are that I'm going to go over. I think I am going to start with converting currencies and Celsius and Fahrenheit because that's a really good sort of base level lesson in algebra that's really important. And that one's important in Math 1102A, so the first of the general math. So I've got quite a few students who are starting that one now. I think there's three who are working on that one currently out of my 21, right? So it's a good one to go over at the beginning. Won't belabor that one too much. We'll be on that one for a little bit. Systems of equations. I might leave that one until a little bit down because I got a fair bit to work on that one. But I'm going to show solving systems of equations at least two ways: substitution and elimination methods, which are both really good. Converting units of area and reading formula sheets, that'll be pretty quick. I'll Yeah, so I'll start with the currencies and the Celsius and Fahrenheit. Then I'm going to do some converting units of area because that's the most similar topic there. Then we'll do interest. Then we'll do solving systems of equations. So how's about, nah, whatever. I won't spend the time to edit the order there, but I will switch on over. And now let's get to that one. So for currencies, like I said, I'm going to use Math 1102A here. So this is the Math 1102A study guide, right, that I've got brought up over here on the side. You can see from this one what sections that is that I'm going to be working in. So it starts here, right? Consumerism and travel. And it does a little bit at the beginning. I'm going to skip past a little bit of that, and I'm going to show 1.2 here, these currency exchange ones. Now, I'm not going to work down through the examples from the notes because you already have those, like these ones here. Those are perfectly fine examples too. But I'm going to go ahead and do some examples of the ones that they ask you to do. So I'm going to go do some of these here, right? Because as you know, these notes aren't required for marks during distance teaching, not in the level 3 courses. You can still submit them for sure. It's a little bit of a pain to do it because you'd have to like take pictures of it all. You can still submit it and I'll go through and we can talk about whatever ones you had a problem with or whatever. But there won't be a grade on it and it won't be a priority to really get to because so yeah, my recommendation is to still do them for your own purposes because it is super valuable. But where you've got the solutions are at the end of your manual, right? Won't go over it a ton. But so I'm going to go to the ones from the notes over here. So here we go. Oh, that's the next ones I want to get to. So I want to start off with page 22. Just keep on scrolling up. It's good content, right? It's good content. Just scrolling through a PDF, It's good. It's engaging, right? It really keeps the new followers, like, liking and subscribing and all that jazz, right? Although we don't say that here. Like and subscribe, no, no, that's different. Although you can't sub to me yet. No, I'm not. Not, we're not aiming for that affiliate thing, at least not quite yet. Maybe not on day 16. Maybe not. Maybe not. Okay, so let me slide this guy over a little. There we go. There. Now you can see it a bit bigger. So this is what I'm going to start off with, page 22. Now some of these are really good questions. So this is Math at Work 10, right? And this is going to be page 22. Okay, how's the... Boy, this camera, I gotta tell you, this document cam still leaves something to be desired, doesn't it? It's awfully blurry over there, but at least you guys can see it. Okay. So on January 17th, 2002, one Canadian dollar was worth uh, 62 cents US. Boy, that was not a good year. On that day, how many American dollars would you get for 400 Canadian? Well, how can we figure this out? There are several different ways of doing it, right? Uh, one way we can think of it, right, is if $1 was worth 62 cents US. We know that it's 1 CAD per every 0.6213 US dollars, right? So now this is a ratio that we have. We know that this is always going to be true, right? Because that was just the ratio that they were using at the time. But then we're told that we're looking for 400 Canadian. So if I put 400 CAD over an unknown number of US dollars, all right? So this is what we're saying. This is our conversion factor over here. Conversion factor is there. This one over here now is the numbers that we're using from the question. So what we're going to do now is we're going to do what we call cross multiply. Oh, pretend I can spell right, I'm only an English teacher. Anyway, it doesn't mean I know how to spell. Shut up. Cross multiply. So I'm going to go ahead. What cross multiply means is, to show you what cross multiply is, this is a really good aside for right now. Cross multiply is when we have a over b equals x over y. That, when you cross multiply, it becomes ay equals bx. So basically this comes up here, this comes up here, and we call this cross multiplying. Right? That's a really good, oh, there we go. Scrolled over a bit. There we go. That is a really good aside to remember how we go about doing these ones here. And it is with cross multiplication. So we take the bottom and move it up, right? So just like over here, the y came up by the a and became ya. So here the x comes up by the 1 and becomes 1x on this side. Then we have our equal sign. Same as over here, the b came up to the x. Like oh, by. What am I doing? Boy, oh boy. Boy, oh boy. Okay, we got there eventually. That's the important part. The important part is getting there eventually. Equals 0.6213 times 400. X is equal to, then we just go ahead and multiply. Get my old friend TI-84 here. $248.52. Okay, so now we know that that's in CA, I'm sorry, that was USD. That was USD because that's what the question was asking us to find. When we're doing the cross multiplying, we kind of have to remember where the X was at first, and then we can go ahead and do that like so. Uh, and the next one, CAD was worth $1.07. Ah, that's more like it. I mean, that was probably like for a day, right? Um, Tell you what, 1B is a bit too similar. I'm going to go on and do 1D. Oh, sorry, not 1D, 2A. 2A. So then for 2A, you have 300 USD when a US dollar is worth approximately $1.10 Canadian. So I want to arrange it like this. Okay. So here now, I've still got CAD on top and USD on bottom. I'm doing it this way so that you can see that sort of either order of these is going to work out to be the same thing in the end, right? Although, look at this, my camera's back. Camera's back to showing the blues and the reds and stuff. It's good, right? So, $1.10 CAD over $1 USD is the one that we have in 2A for our conversion factor. And then we have how many Canadian dollars will you get for your American money? So you have $300 American. So some unknown number of CAD over 300 USD, right? So again, now for this one, I'm going to cross multiply. So I wasn't just blanking on how to spell the word. It was actually being distracted by something else. Anyway, 1.10 times 300 equals 1 times x. And of course, 1 times x doesn't do anything. 1.1 times 300 is, of course, going to be 330. 330 equals x. So it's 330 CAD. That's all you have to do then for the cross-multiplying method of converting currencies, right? You always make sure that in your ratio, you have the same currency on top both times. So the same currency needs to be on the top of both fractions and on the bottom of both fractions. Okay, so let's see, that's a reasonable start there for the currency conversion. So let's go on down now to, let's see, I wanted to do page 26 as well. Let me see, what was different about page 26 that I wanted to do it? Oh, okay. Okay, good. Yeah. Yeah, let's do a little bit on page 26 as well. Okay, so in question 1 here, let's do 1C. So, it's going to be 435 CAD to GBP, Great British Pounds. Okay, those are the normal abbreviations for those currencies. So what we can do is we have two different sort of charts here, as you'll notice. Oh, my cursor is gone. Over here. So we have two different charts, right? And it says one CAD is this, or in Canadian, it's that, right? So that's a bit of these are a bit oddly phrased, and I do find that probably the most difficult thing about any of these is how these guys are phrased. So it's going to be 1 CAD per every 0.616697 GBP. Right? I know it's a long sounding decimal, but that's the decimal that you're going to have to use for this one. And we see that over here in this chart right there. British pounds, that one. Right? It's that one there. And then it's going to be, well, we know we have 435 CAD, and that's going to be some unknown number of British pounds. So now I'm going to go ahead and multiply, cross multiply. So I'll write that out here again. Right? And it's going to be x equals 435 times 0.616697. X is equal to 268.26. And that's GBP. So we knew that one from the start, right? And that's just to show how we write out, say, one of the conversion factors from the first column here, right? And now if we're using the second column, that's going to be like 1D over here. So that one then has in C there on the top. Well, what does that mean? Well, I'm just going to use that one for the yen one. But what that means is when it says in C dollars, right, that needs to be what's on top then. So if we had 0.012134 CAD per 1 yen. I don't actually know off the top of my head. JPY, I think, Japanese yen? I'm pretty sure it's JPY, isn't it? I think so. And of course, we know that a yen corresponds to a cent. So there isn't really like, I mean, yeah, it looks, we're saying what, like 1.2 Canadian point, not 1.2, 1.2 Canadian cents for every Japanese yen is what this is saying, right? Basically. And it doesn't mean that Japanese money is not worth very much. It's just because it corresponds differently, right? They don't have a dollar equivalent. They have a cent equivalent instead, right? And now we're looking for still 435 CAD. So we still put our 435 CAD here. And now we have our XJPY here on the bottom. Now, one reason why this is such a great example is because now once we multiply, once we cross multiply, God, I did it again. Once we cross multiply, we get a 0.012134 times x on the left, and we get our 435 times 1 on the right. Well, now what the heck do we do? Right? We don't have x equals something. What in the world do we do? Well, what we had to do now is because of the way the cross multiplying has gone, we've got one more step we need to do because we need to get x by itself. Right? To get x by itself, we're going to need to divide both sides by this number here. So we're going to have x equals 435 divided by 0.012134. So x is going to equal 435 divided by 0.012134, 35,849. So it's 35,849.68 CAD. Where it's money, I'm going to round to 2 decimal places for Canadian dollars, of course, because, cents are as low as we're going to go. So that is a good look then at the conversion of units of currencies. So for Renetta and Lucas, for example, those are going to be very important topics that you're getting to immediately. For Carly, for example, that one will be very shortly coming as well. So I hope that was useful to you guys. Number 34 as well. So estimate and calculate the following temperatures in Fahrenheit. Estimate and calculate in Celsius. Well, I'm not going to do the estimation part. The estimation part is so much junk, basically. Like, estimating is just sort of demonstrating that you can get in the ballpark. But I'm much more interested in seeing if you can calculate them. Right? So this is going to be page 32, which is another one you had to do in the notes. I'm going to start off, I'll do these in green and red just to keep them distinct from the others. So this is, I'll do 1A, but 1A then I believe I'm converting, what am I converting? Celsius to Fahrenheit in 1A? Yes, I'm converting Celsius to Fahrenheit. So we're told from page 32 over here, just on the left, right? You see that down here at the bottom? You give that a circle, this part here. We can see from there that degrees Fahrenheit is equal to 9/5 times degrees Celsius plus 32. Now, it's a pretty inelegant conversion, of course, but that's because these are two totally different temperature measurement systems. They weren't designed to equal out one to the other, and even this is sort of an approximation, right? But what we have is a formula now that, even though it looks a bit complicated, it's pretty straightforward because it's all math that we have seen before at various different points, right? Scroll down and get a bit of that color on the screen. That's nice. So I'm going to do the first one, like I said, which is, what is that? 28 degrees Celsius. So what I'm going to do is degrees F equals 9/5. I'm going to put in the times 28 here because that's the degrees C that I'm going with, then plus 32. Now, 9/5, well, what is that? Well, I know, say, Lucas, for example, you haven't, you might not have done math for quite a while, so it's going to be very useful to you to remember how we go about doing these. So 9/5 is just like that, right? 9 divided by 5, 1.8. So that's fine, right? So it's equal to 1.8 times 28. You needn't write out all these steps, but I'm going to go through and do them out anyway. So we have our 1.8 then times our 28. It's going to be 50.4. So that's 50.4 plus 32. So in degrees Fahrenheit, we're going to have 82.4. Okay. So let's go on down to then 2A. And that'll be the last one that I'll do for these Math at Work 10 ones. Right? If you're working on this, I know several people are. You can send a message if you need any more questions done on these topics. But yeah, doesn't seem like there's a whole lot of advantage being taken of the resources that are being provided to people. Right? I mean, it's a lot of work for teachers to get these resources put together for something like social distancing. I'll tell you that much. Okay, so for the other one, we're converting Fahrenheit to Celsius. So we've got a different equation, and that's this one over here, right? Oh, we can use, well, this is the generic form. Convert degrees Celsius to degrees Fahrenheit. We got it over there. Temperature in Fahrenheit. Oh, sorry, that's not the one we're going to use. We're going to use, right, we just used that one. we've got to use the other one, right? Because we're putting in Fahrenheit and getting out Celsius. So where have they got that one? Did they even give us that one? Or do we have to derive it? That's a bit more advanced than there would be in this course. They must give us the other one. Oh yeah, it was right there. What am I? Barely paying attention. Look at that. I'm the teacher and I'm barely paying attention. What is even going on? So degrees Celsius is going to equal 5 over 9 outside of uh, degrees F minus 32, right? And we could derive that from the other one. Like if it would be totally fair to have not been given this and expected to derive it from that, but that is a little bit beyond what we would normally be doing in this course, for example. Okay, so here now we're going to plug in the degrees in Fahrenheit, which we were told in the question. So I'm just going to do it on a calculator even. 43. 43 times 5 divided by 9 degrees Celsius equals 23.9. Right, and it's very important, a very important aside, a place where people lose loads and loads and loads of very easily saved marks. Oh, so many marks people lose. This is not 23.8. This is 23.9. It's 23.9 because when you round, the first number you're cutting off determines if you're going to round up or if you're going to stay the same. And if the first number you cut off is a 5 or more, then this one's going to go up. So here, the number I'm cutting off is an 8, so this turns into a 9. Right? So that's why it's 23.9. Or I could call it 23.89, or I could call it 23.889. But the point is, at some point, the last digit that I've got there, as it shows on here, at some point the last digit is going to be rounded to a 9 and not left as an 8. Right? Not everybody makes that mistake, but it's pretty common to see it. And like, I got to take off like half a mark for it, which is tragic because it's a super easy part of it. Anyway, that is the beginning of Math at Work 10. All right, so again, Renetta and Lucas, who are, I believe, currently working on that, should have been very useful to you. So, what was I going to do next? Let's switch back over. Switch back over and see what was I going to do next. Converting currencies, Celsius and Fahrenheit, done. Converting units of area. I don't know. I'm a little disheartened with converting units of area to be honest. I don't. I've done that one so often recently. I'm not sure that students are really seeing any of this. So I'm going to go ahead and do the systems of equations because that's what I need to get done. What I need to get done is this answer key for systems of equations. So I tell you what, I'm going to put a hold on doing those other ones there now. If anyone shows up in chat and wants me to do those, I will go ahead and do them. But for now, then, I will go ahead and do the stuff that I need to get done, and we'll just do it on camera. That'll be fun. Yeah. So one thing that I need to do here now is I need to do up some answer keys for this, because I don't have an answer key right now for this worksheet number 2. So let's get to that, shall we? This is Math 1101C, worksheet 2, answer key. All right, cool. So for question 1 then, all right, question 1, these ones we're asked to do systems of equations by substitution, the substitution method. Right? What does the substitution method mean? Well, there's a whole bunch of different methods that you can use to solve these systems of equations, right? And one of them, like I said, is substitutions, where we take one question, rearrange it, and substitute it into the other one. Now, it always has to be the other one and not the same one, right? Because if we're substituting it into the same one, we're not going to get anything out of it. We're just going to end up with a 0 equals 0, and it's going to be nonsense, right? Because we already know 0 equals 0. It's true. It is true that 0 equals 0, but it's not super useful to us, right? But so I'm going to go ahead and write down my two formulas. So I have x plus y equals 9, and then I also have 2x plus 3y equals, what is that, equals 11? Yes. Okay, so x plus y equals 9. In order to do substitutions, we have to arrange it so that we can substitute, like it says, we can substitute one of these values into the other equation. The way we can do that is we have to rearrange one of the formulas so that one of the variables is by itself. So let's say that I rearranged over here to get y by itself. I can call this y equals 9 minus x, because I've just moved this x over, right? Now, I can sort of take this and substitute it into this one over here. Say 2x plus 3, 9 minus x equals 11. What did I do just then, right? What was that? Well, what I did was I took this equation here and put this one in it in place of the y, because I know that y, from rearranging this, I know that y is equal to 9 minus x, right? And then over here, I can go ahead and say that, well, if 2x plus 3y equals 11, 2x plus 3, 9 minus x, has to also equal 11, because 9 minus x is equal to y. Once I know this, now I have an equation with two variables in it. Well, sorry, an equation with one variable in it that formerly had two variables. The equation that had two variables is now an equation with one variable, which means I can solve. So I can just go ahead and start simplifying all this. 2x plus 27 minus 3x equals 11, right? So now we have 27 minus x equals 11. 27 equals 11 plus x. I'm just moving the parts around. You can do this in lots of different ways. But as long as you get to 16 equals x, you know you've done that one correctly. 16 equals x. Now you can just go back and put this back into over here, right? So I can have y equals 9 minus 16, because I just sort of took this and put it back in over there, like so. And we can call this then y equals -7. There we go. Easy stuff, right? Now, let me show you as an aside what would happen. Let me show you as an aside over here. So let me move over a different piece of paper because I don't want to put this on the answer key. But let me show you what would happen if I went ahead and substituted back into the same equation, right? So x plus y equals 9, and then I rearrange that to be y equals 9 minus x. Now, a mistake that I see that I personally have made made a few times before, and then realized that something was wrong and all my work was wasted. One mistake that I made before is substituting this back into the same one that it came out of. Now, it's fairly obvious here what's going to happen, but if we have a bigger equation, like you might get later on, it might not be so obvious at first. Maybe you lose track of which equation you're sort of rearranging, and then you end up substituting back into the same one. You end up wasting all your time, because look what happens. If I have 9 minus x and substitute that in here for the y, look what happens. X plus 9 minus x equals 9. So x minus x is 0, so I have 9 equals 9. Or if I subtracted 9 from both sides, I'd have 0 equals 0. Right? Either way, 9 equals 9, 0 equals 0. They're not, I mean, they're true, but they're not incredibly useful to us. Right? So if you substitute back in the same one, you're just going to have your variables all cancel out. And what you're going to be left with is going to be true, but kind of pointless. Okay, well, I'm going to go ahead and do question 2 then. 5x plus 2y equals 6. X minus 4y equals -1 are the two formulas that I have. Right? So I have to rearrange one of these so I get the variable by itself. So I'm just going to move this 4y out of here. I'm going to call this x equals -1 plus 5y, or 4y. Not 5, no reason for it to be a 5. That's a 4. Okay? So now I'm going to take this and put it into that equation up there, right? So what I'm going to have then is 5 times, I'll call this 4y minus 1, just to have fewer symbols there. It's the same thing, of course. 5 times 4y minus 1 plus 2y equals 6. 20y minus 5 plus 2y equals 6. 22y equals 11. Y equals 11 over 22, or y equals a half. Hey, there we go. Now we're getting somewhere, right? Y equals a half. Now I'm going to go ahead and I'm going to put that back into this equation up here, right? So I'm going to substitute now y equals a half. This one I can put into either of these. Like once we get the variable by itself, I don't have to worry then about which one I'm substituting into. I can pick either. So just to show you, I'll even go back and pick the same one that I did originally, and well, I did over here too, right? But we can pick either one. Yeah, I'll just do 5x plus 2 times a half equals 6. I think you might even already be able to see what it's going to be. 5x plus 1 equals 6. 5x equals 5. X equals 1. There we go. Right? Good stuff. So our point of intersection there for these two lines is going to be x equals 1. Okay, so I'm going to move on there now. I'm going to go ahead and do some these elimination method questions. Right, so Betty Ann asked for these ones. So I'll go through and do some of these. This is going to be worksheet. Okay, so for these ones, we're asked to solve these by elimination method. Now, what is elimination method? Well, it's going to work out the same as the other one. So on plenty of activities, you'll be told just to sort of pick one and do that. Screen. Like it's not. My headphones aren't even remotely green. Like, oh my God, this chroma key, I tell you. Anyway, so question 1 here then. X minus y equals -2. And we have -2x plus y equals 7. Okay, so for elimination method, what we're going to do is we're going to try to get it so that we can add or subtract one of these from the other one, in order to fully cancel out one of the variables, right? So here, for example, we have a positive 1 on this x, right, and a negative 2 on that x. So they don't have the same coefficient. They either need to have the same, exact same coefficient to subtract them, or they need to have opposite coefficient, like one positive and one negative. Then we can add them, right? So here now, the x, this one has a positive 1 and this one has a negative 2, so we can't do anything with those. Well, we can, but we're not going to use those, at least not as they are. So let's see if we can use the other one as it is. This one has a negative 1 on the y. This one has a positive 1. So, yes, we can use that one. We can go ahead and add both these together. So I'm going to put an add symbol down here. And then I'm going to write out like I'm adding this full expression to it. X minus y equals negative 2. So what I'm going to be doing is I'm going to be adding each of these terms up, sort of in order here, right? So negative 2x plus an x is going to be a negative 1x. A positive y plus a negative y is going to be 0y, so I can just leave those out. And a positive 7 plus a minus 2 is going to be a positive 5. So now I'm all the way down to negative x equals 5. Now, of course, I don't want negative x, I want positive x. So I can multiply both sides by negative 1 and end up with x equals negative 5. Okay? And now, just like with the other one, I can go back and I can put in whatever I want here. I can put this x into this one, or I can put the x into that one. It's going to work out the same way, right? So let's say I have negative 5 minus y equals negative 2, right? Because that's putting this one back into that. Then I'm going to go ahead and switch the y and the 2. So I'm going to have negative 5 plus 2 equals y, or negative 3 equals y. So there we go. That is the point of intersection of those two ones there. Now, this is an example of a relatively easy one because I didn't have to do anything with the numbers first, right? So it's a fine first example, but it's not really a great example because it needs to be showing more of the twists and turns that you can end up encountering as you're doing these. Okay, so I'm going to go ahead and do question 4. Okay, so here now we've got a negative 10x up here, a minus y, a plus 24 equals 0. Down here we've got a negative 1x, a positive 3y, and a plus 15 equals 0. Now the constants, we don't have to be super concerned with canceling those out. Those guys will sort of take care of themselves. What we need to be concerned about here is making sure that either the number of x's or the number of y's cancel. Okay, so how do we do that? How do we make sure that they cancel or not? Well, we can treat these equations just like any fraction, right? As long as we do, because as long as we do the same thing to the top and the bottom of a fraction, then it works out to be the same. The same way, we can do the same thing to the left and the right side of an equation, and it's going to work out to be the same as well. So here now, I'm going to take this one, 10x minus y plus 24 equals 0, and I'm going to multiply both sides by 3. Really, this is what's going on, to be more accurate. I'm taking both sides of the equation and multiplying both sides by 3, right? So then I'm going to have 30x minus 3y plus 72 equals 0. Still equals 0, because of course, 0 times 3 is 0. Now, I can take this one and bring this guy back down. You don't have to do the working out the same way I'm doing it with all these arrows stuck all over the place. But negative x plus 3y plus 15 equals 0. So now I can go ahead and add, right? Because now the negative 3y and the plus 3y, those guys are going to cancel, right? And that was the point of doing this in the first place. So now I'm going to have 29x plus 72 plus 15 is going to be 87 equals 0. So 29x equals negative 87. 29, negative 87 or 29, that should be negative 3, right? Negative 87, that's right. Yeah, negative 87 over 29. It's going to be negative 3, yes indeed. Equals negative 3. There we go. Now don't be fooled. Don't be fooled. Just because it works out to look like it's something sensible, that doesn't mean it is. That doesn't mean it's right. It just means that, because sometimes you'll get an answer and, it'll look like it works out to something nice and even, and it won't be the right answer. Sometimes you'll get a massive monstrosity of like, 2 3-digit numbers divided by each other and a lowest term fraction. You're like, this doesn't make any sense. This can't be the right answer. And sometimes it is. So I try to always caution people against sort of metagaming these and thinking because they got a right answer. Got a right answer? Well, if you got a right answer, it's right. Thinking because you got a whole number that means it's right. It does indicate that it's probably right, though. Right, so now I can go ahead and substitute back into either of those. So I'll have a negative 3 plus 3y plus 15 equals 0. So that is going to be 3y plus 18 equals 0. 3y equals negative 18. Y equals negative 6. There we go. So that's question 4 down. Y equals negative 6. So I was asked to do a few off this sheet, so let's do one more off this sheet here now. Now, what's a good example one? And that one's actually a bit too, 12 is a bit too easy, actually. Let's do 11. Let's go hard. Let's go ham. Let's go ham-a-lamb, fam. I'll never say that again. I will never. Even just coming out of my mouth, it didn't feel good. No, boy, oh boy, boy, oh boy. Yeah, let's do number 11 because it's a good one. There we go. Oof, big oof. Large egg. Gros oof. C'est un gros oof. Voici le gros ouf. Où est la salle de bain? Ouvrir la fenêtre. My friend, I have the French of a Canadian 6th grader. 1 over 3 x plus 1 over 6 y equals 5 over 3. Then the next one we have is 1 over 2. I'll do these side by side this time because it's a bit neater to do it side by side. 1 over 2x minus 1 over 4y equals 1. Okay? And I'll put another line over here, although it should be obvious that the reds are with the reds and the blues are with the blues. So now over on this side, we see that we can't evenly multiply these guys by the same thing to make them work, right? Because there's nothing we can multiply 1 over 4 by to turn it into 1 over 6. Is there? Well, I mean, yeah, there is, really. It's a bit of a pain, though. Right? We can multiply this by 4 over 6. Right? And this by 4 over 6. And that will get us over to here. What I would recommend doing when we have one like this is basically multiplying both sides by a number to sort of get rid of the fractions in both sides. It's probably the easiest way to do it. There's a whole bunch of different ways you can do these, what numbers you can pick. And, the book shows you some ways. What I would recommend doing is say, I would like to multiply this fraction by something to get rid of the coefficient in front of the x, so it becomes a 1, and I'll do the same over to here. So I'll get this to have 1x and this to have 1x. Then things are going to look a heck of a lot easier by the time we're done. Right? So what I'm going to do is I'm going to take this full one, I'm going to multiply it by 3. Right? Both sides of that one are going to be multiplied by 3. So we're going to have this 3 cancels with this 3 for the x, and it's going to be just 1x plus, it's going to come 3 over 6, or 1 over 2y, and that's going to equal 5 over here, because the 3's are going to cancel with the 3's. Then over here, I'm going to recommend multiplying both sides by 2. Oh, running out of space. But I think you see where I'm going with this. It's going to just have an x again. It's going to be minus a half y, and that's going to be equal to 2. Now, inadvertently, I also got the y's to be the same as well. Right? But this is still totally valid, because everything we've done on every step here is a thing that we can do, right? You can totally multiply the left and the right of an equation by the same thing, and it stays the same. I can multiply the left and the right of this one by the same thing, and it stays the same. I'm under no obligation to multiply both equations by the same number, or even to just multiply one. I can multiply both of the equations. So now I've got these ones here, and I can just sort of pick. I can pick which way I want to do this. So I'm going to have this be x minus 1 over 2y equals 2. And yeah, I'm gonna go ahead and add, just because it was neat that that worked out, even without really trying for that one. But I can go ahead and add these, and then I'm going to get 2x. The y's are going to cancel, and it's going to become 2x equals 7. So x is going to then be 7 over 2. And it's totally fair to leave it as 7 over 2. You don't need to call that 3 over 5. You don't need to call that 3 and 1 over 2. You can leave it as an improper fraction, and that's fine. Now I can go and take this and put it back into the other ones. So I have, say, 7 over 2 plus 1 over 2y equals 5. Okay, I'm going to go ahead and subtract. 1 over 2y equals 10 over 2 minus 7 over 2. No, excuse me. It's 10 over 2, of course, because 5 is the same as 10 over 2, obviously. So we're going to have 1 over 2y equals 3 over 2, like so. And then go ahead and multiply both sides of this equation by 2. We're going to have y equals 3. Easy. There we go. X is 7 over 2, and y is 3. This is about as hard as it gets on this sheet. So I think that one should be a good example. So Betty Ann, there you go. That's 3. 3 ones done for that that assignment, right? Boy, it's an awful lot of free marks to get. Boy, it's devious, I tell you. He's trying to get people to watch the stream by giving them answers to questions. He doesn't do that most of the time. He doesn't do that for me in school. It is what I do all the time, Twitch chat. It is. I am constantly answering questions. But all right, what do we have next? Let's see here. How about we switch on back over to my intro? Switch on back over to the intro. There we go. Oh, yesy duckies. So converting currencies done. Converting between Celsius and Fahrenheit done. Systems of equations done. Converting units of area. Okay, yeah, let's do a little bit on converting units of area then. Switch on back over. Wow. Actually, let's go to this one. Let's go back to this one over here. So I'm going to bring up this one. Yes. Review sheet 3. Okay. So converting units of area. See, what I want to do. Do question 8. Right. Yeah, so really quickly, I'm going to go down through question 8 over here. So I think I can switch on back over to my other display so I got a little bit more space to work with. There we go. Good stuff. Now let's zoom this guy in a bit. Zoom in There we go. So how about I go through, I'm going to go through and do out all of these ones, right? Just because I want it to be really clear what we're doing here with converting units of area. So I'm going to call this converting units of area. Oh, there we go. Scroll E down. There we go. Converting units of area. So this is going to be 8A. Start off with that one. So 504 inches squared equals blank feet squared. Well, we just divide by 12, right? No, no, you don't. You don't. You do not. You do not just divide by 12. You know why? Because there's a squared in the corner. That squared in the corner is super duper, really ultra crazy, super mega important. Because in squared is not the same as in. Feet squared is not the same as feet. They're not. They're not the same. And let me show you, right? We're going over onto reading formula sheets. And the thing is, right, if we switch on over to the formula sheet that exists for that we give out, sorry, for that one, we'll see that it's actually there. It's actually right there. Oh, did I close the formula sheet? Oh, I did. I did close the formula sheet. Hold on, just a quick second there, Twitch chat. I will have the formula sheet. There we go. There's E. Gotten. So now zoom out a little so we can see it all. So this is the formula sheet right here. Well, what? How in the world are we, the nice thing about this sheet is this sheet actually gives you the conversion factor right there, right? It's literally, it's right here. You see this? 1 foot squared is equal to 144 inches squared. It's not 12. It's not 12, it's 144, right? And it's really tragic to see people losing marks just because they're not understanding what this 2 in the corner means. The 2 in the corner means that it's a totally different unit. It's no longer just feet. It's feet squared. It's no longer just inches. It's inches squared, right? So let me show you. Let me show you actually an actual, factual, contractual drawing of what this is. Now, as you see, my ruler here is in centimeters because I am in Canada where we use the metric system like civilized people. But it's about 2.54 centimeters to an inch. So I'm going to do 2.5 and then a little tiny bit more. So there we go. So that's about an inch. So that's 1 inch. That's what it is. It's a measure of distance. Right? But over here now, 2.54 and there we go, about halfway between 25 and 26 millimeters. There we go. So this now, I'll make sure to come off it at a right angle by using Dissen. And then a right angle down here as well with this. There we go. So this is 1 inch squared area. Right? And it's totally different. It's a totally different thing. And I know that it's really small. It's just this little 2 up in the corner. So it's really easy to think reflexively that an inch and an inch squared are basically the same. But they're not. They're a totally different unit that measures a totally different thing. Right? So an inch measures distance, its length. An inch squared measures area. Area is how much space something takes up. Distance is long. Right? So we can call this also, another way we can think about it, is this has 1 dimension. This has 2 dimensions. And if I had an inch cubed would come out of the paper. It would be in 3 dimensions, right? The little 3 in the corner. It says how many dimensions it is. Another handy thing we can think of when we're imagining these is that an inch Well, an inch has an exponent of 1 in the corner. We don't see it on here, but it is there. There's an unwritten 1 as an exponent to every number that appears to not have an exponent, right? And that 1 in the corner for something like inches, that tells us how many dimensions it is. This is actually 1 dimension. This 2 in the corner, right? When we write it in, because it's anything other than 1, we write it in. That tells us there's 2 dimensions. If we put a 3 in the corner, that'd be 3 dimensions. 4 in the corner would be 4 dimensions. Now, of course, 4 spatial dimensions don't exist in our reality, but maybe there's parallel universes where people have like 7 and 8 spatial dimensions, and they're all like, you know, looking down their noses at us like 3 spatial dimension plebeians over here. I'm sorry if I'm like confusing people needlessly with my gobbledygook talk. Anyway, that last part was not important. Okay, the important part is knowing that an inch squared is a 2-dimensional thing, but it's a measure of area, and an inch is a measure of distance. And an inch squared is not the same as an inch. A foot squared is not the same as a foot. 1 foot equals 12 inches. Yes, but 1 foot squared equals 144 inches squared, right? And there are plenty of other conversion factors as well that you'll be seeing coming up. So these ones here. A yard squared is equal to 9 feet squared, right? Because a yard is 3 feet, but then the space of a square yard is 3 feet by 3 feet, which is 9 feet squared, right? So if this was, we'd say 1 yard, this would equal 3 feet, right? It would be the same thing. But if we had a space that was like so, it's 1 yard on this side, which is the same as 3 feet. It's 1 yard on this side, which is the same as 3 feet, right? But it's actually going to be, the area here is going to be 3 times 3, which is 9 feet squared, right? And that's why 1 square yard, no, well, 1 yard is equal to 3 feet, but 1 yard squared is equal to 9 feet squared, because you're squaring your conversion factor, right? So up here, we know that we have to, for question A, right? I've really belabored, I haven't really gotten to question A yet, but I mean, the explanation of the question is honestly more important than just grabbing the answer, because you got to know why. You got to know why this is the answer, and you got to know how this sheet over here that you're given on your tests is going to be really useful to you, right? So 504 inches squared equals blank feet squared. There's a few different ways that we can go about doing these to convert them back, but I'm just going to divide by 144, right? But what we could say, there's a few different ways we could do this. We could say that 1 foot squared per every 144 inches squared. Now, Ashley, you've been doing very well using the cross multiplication, so I'm going to keep showing that method. It's just the important part for these ones is really just remembering that you have to use this different conversion instead, right? Because all the hard stuff, all the actual like math computation, you're doing really well, and it's really too bad to miss out on marks because you're using the wrong conversion factor. Right. So then, where have I lost my train of thought. Right. So some number of feet squared per the 504 inches squared that we got up here, right? And now we can do our cross multiply. I won't expect you to write out cross multiply like this. I just write it out because I want you to realize sort of what step I'm taking here and what we call it. So we call that cross multiplying. So I'm going to go ahead and multiply across here, and I'm going to have 504 equals 144x. Now what in the world do I do? Well, I got to get rid of this 144, right? I got to divide by it. So we're going to have 504 divided by 144 equals x. And you might have known to do that off the top, right? 504 divided by 144. It's going to be 3.5. Put that over here. X equals 3.5. We're still on the page here, only just. Only just. Okay? So let's switch on back over to this scene. We see then that's how question A is going to go. So let me pop back over here. There we go. So let's now do let's do E. Let's do 8E. And I'll do this one in a little bit of a different way, but it's still going to be super useful to know. So this is still converting units of area. Oh, I'm zoomed into. How do I keep getting zoomed in further than I want it to be? There we go. Converting units of area. So this is number 8E, 80. Right? So we have 6.7 feet squared equals blank inches squared, like so. Okay, so there are several different ways that we can do these. And like I said, I want to show you another way. It's not, well, it's not really another way. It's kind of the exact same thing that you've been doing, right? But we can just multiply this by our conversion factor. But we know the conversion factor is there's 144 inches squared per 1 foot squared, right? And we can think of that as 144 square inches per 1 square foot. And that's just a way that we can, boy. Yeah, I'm gonna have to write a little bit bigger. I have to write a touch bigger. That's 144 square inches per 1 square foot, right? And we know that from our formula sheet. We were told that one. So I now can go ahead and multiply those, because what we have is 6.7 feet squared multiplied by 144 inches squared per 1 foot squared, right? And now, like I showed before, if we leave our units in there, it can help us greatly to figure out what conversion factor we need to use. Because we know now that our feet have to cancel with feet. The feet squared cancel with the feet squared, and we're left with inches. So really what we're doing here now is we're multiplying. We're going to have 6.7 times 144. And that's going to be left in inches squared, because that's the unit that's left over, which is what we want, because it's what we were looking for off the start, right? 6.7 times 144 equals 964.8. 964.8 inches squared. Right? And I think this one does bear repeating again, right? Because the only thing that people ever find difficult about these ones, honestly, well, not ever, but the hardest part of these is actually kind of the easy part, if that makes sense, right? Because it's easy to remember to use 144 instead of 12, because you just got to remember, right? The hard part is doing the math computation right. But plenty of people do the math computation right and then just blank on the fact that they've got to use the different conversion factor, right? So it is worth noticing and practicing these guys, because they're easy mistakes to make, but also easy marks to get right. Because the math you already know, you just got to remember how to do the conversion factors properly. And yeah, I think I'm going to hold off on doing some of the other topics that I mentioned on the intro today. What did I have left? Calculating interest was the only one I had left. Yeah, yeah. The student that oh, there we go. The student that needed calculating interest is not here, has not checked in at any point. So I don't feel like I should go over that today, because Yeah. Anyway, yeah, so that's gonna be it's gonna be all for today, folks. Thanks for thanks for joining me. Um, I hope that social distancing is going well and that the stream is useful. It's yeah, it's I'm glad to be here doing it to help people as much as possible. Something to keep busy, you know. It's, it's better than you know, better than sitting in a basement all day just waiting for time to pass, I suppose, right? There you go. Might as well do some work at the same time. All right. Well, hope hope your week is going great. Um, yeah, see you tomorrow and stay safe.